on the t-squared chart? Okay. So I'm not going to do this a lot, but I want you to remember, we were able to look up z-scores before I ever gave you the t-squared chart, and that kind of shit, right? So it's going to be a two-tail test. There's got to be a total of 0.005, so how much would each tail have? 0.025. Can you look that up in the z-score chart? Because the t-score chart don't got that. Another example of why I should never teach English. I don't know if you guys see what I'm saying. So you got to remember, getting z's off the t is a shortcut. The shortcuts always work. No. So the situation wasn't one that was on the t-score chart. Okay, I got to do like we always used to do. Cut that in half, look it up. What do you guys get for the z-score? You get an Yeah, that sounds about right. So 0.0025 is right there. Negative 2.81. So 2.81 on both sides. Okay. Let me stop for a second, you guys. We've seen this before. This is the unfortunate thing about learning some shortcuts. They very often only work in some situations. You have to remember the long-ass way to do things if you're not in a situation where the shortcut works. How do I say this in words? It's going to be something a little bit different here because now how many ways is there to show evidence? 2. So if z star is greater than this one, or if z star is less than that one, that's exactly what you say in level. So if z star is greater than 2.81 or z star less than negative 2.81. What can we do then if that's true, if we get out there? Reject the null, support the high. Otherwise known as reject the hoe, support the high. Sounds like propositions we could do. All right, let me stop there for a second. Is everybody? So that's how you handle a two-tailed test to interpret when to do the thing. When is there going to be enough evidence if I get into the rejection region, but now it's in 2 places. Above that one and below that one. Oh. Yeah.
Could you condense that into one conditional statement if you use the absolute value of z?
Yes. Any further use of algebraic symbols will those, especially if they're used correctly. A little tear will come to my eye. You don't get bonus points, but hey, you save a little bit of graphite. Let me think. Is everybody cool with that step there? It's the same as before. The only difference was we couldn't do the shortcut of the t-score chart. Oh well. All right. Notice that this is kind of like the way I'm going to ask this kind of question. I try to be very vague so I don't give anything away, right? Because if I just said C or Z, and then you would know, which one it's supposed to be. We know it's Z now. So what do we know from the sample? What was X bar? 25.29. What was S? I'm sorry. Sorry? What was sigma? 3.15. And what's N? 264. So what's the new standard deviation? Dude. .1939. 194? Or 1939 is fine too. Is that what you guys got? Okay. Now make your Z star. or something? So it's always our data minus the supposed middle divided by the appropriate spread. I think it's 2.4 something. I don't know. It is? What is it? 2.47? Kick ass. There's one funky little thing. Is everybody cool with that? Do you guys get that? There's one funky little thing about the p-value. Let me see. All right. I need some paper. Paper. The kingdom for paper. All right, here we go. What are you? Nothing. Okay. All right, now watch. Where in this picture, this is the rejection region, is that cool? Where in this picture is alpha? Yeah, so where is it? It's in the shaded regions, right? It's in two places. It's been kind of split in half, hasn't it? So to recapture it, I would take one of these and double it. Does that make sense? So alpha is the area in the tail or tails of the rejection region z-score. Is that all right? In fact, that's how we find the z-score, is we say, here's the area, let me look up the z-score. That's how we do it, right? Okay. P-value is the analogous area for z star. Oh shit. What, Jeff? So the p-value is the area in the tail or tails of my z-score, my z star, right? This is a two-tailed test, though. So first off, we got 2.47, right? So what's that p-value? My picture is really not to scale, but too bad. What's the p-value, or what's the area in the tail of 2.47? 0068? Okay. So when you look up 247, you get 0.9932. That is not, Jeff, there's one more up there. That is not the p-value, though, because the same way that this is in alpha, you have to double it. That's not the p-value yet, you have to double it. So when you have a two-tailed test, to get the p-value, you double the area. Just because it's supposed to mean the same type of thing that alpha does. I don't know if you guys get that. All right. So what's the p-value going to be in this one? 0.0136. Double 0.0068. It's just 2 times that. Now the reason for that is did we make it in the rejection region? No. Therefore, the tails that our z-star makes will be bigger than the tail that this guy made, right? Or in words, if the p-value is bigger than alpha, we failed to reject. It's just another way to do the test. I don't even need this number, to be honest, because I can compare my p-value to alpha directly. So our p-value is 0.0068. What was our, 0.0136. What was our alpha again? So this is bigger than this. If the p-value is bigger than alpha, we failed. If it's the other way around, we succeeded. Okay. And on one level, I want you guys to realize that kind of seems silly because we know the answer before we even calculate the p-value. But there's something about real life that I'm going to drop on you in a minute once we get this thing really done. Whatever, Jeff. Real talk, kids. No. What's our conclusion then? So right here we can say, did we make it? No, we failed. We suck. Failed to reject the null. Failed to support. There it is, Jeff. The high. So either you reject the null and support the high, or you fail to reject the null, fail to support the high. Those are the things that could happen. There's really just two things.
But we never reject H1.
No.
We only fail to support it.
Yes. It's exactly like a court case. A court case is exactly like this. What is the prosecution trying to show evidence of in a court case? What do we assume is true? What's our null hypothesis in a court case? What do you assume to be? I don't care about, let's talk about what it's supposed to be, okay? Not what it very often is. You're supposed to be assumed innocent until proven guilty, or actually enough evidence, right? Within a reasonable doubt, which means it's not really proof. It's just enough evidence. So our HO in a court case is innocent. And then what's the prosecution trying to do? Show enough evidence to reject that. Exactly. They're trying to show enough evidence to reject that. That's why, in some cases, the defense doesn't do shit because the prosecution sucked. They didn't show shit, so we're like, we can rest so we can get out of here. Right? But of course, most of the time we're going to say something. Are you semi with me? I know you all are somewhat aware. Maybe some of us are more aware about how court cases work than others, and I'm sorry if that's true. I understand. Trust me. Anyway, so that's kind of nice to realize that this has the exact same feel to it as a court case. You accumulate evidence. The jury is supposed to decide, is the evidence presented enough? So it's not quite, you can't draw a picture and have it, does it fall above 2.97? No, it's sort of subjective, but it's still the same format. Okay, maybe. Where am I at? All right, so we failed at shit. Now, what was our claim? Unfortunately, again, what was our claim? Which one? Which one of these was the claim? H1, right? Wasn't our claim not equal to? Therefore, when I go to write my conclusion, I'm going to use this language. There is zero ambiguity about how to word the conclusion. Zero. It's got to reference the claim. So how do I interpret this? Failed. We have not found sufficient evidence to support the claim that plagiarized. We failed, so we have not found sufficient evidence. To support the claim that what?
The average age.
The who what?
The
Average age of women at first birth changed from 24.81. Or you can say changed from what it was in 1990 or whatever. All right, so here's this is a perfect time to take a little break from doing these tests. I want to show you something. Let me let you guys finish writing that down. And I want to show you, I actually managed to find a decent study here. It's really interesting, actually. It's kind of freaking me out a little bit. How's everybody doing? Everybody got that? Okay. Okay. This is a study. Now read that title. This is really fascinating. I know nothing about this. I just found this. Human body temperature apparently has been decreasing since the Industrial Revolution. That's really funky. We're all becoming snakes. No, I don't. So, look at, let's see, wait. Let me find you a couple things to show you. Yeah. What do you think these are? This right here. Could be confidence interval. They didn't really say. It might be just a range of stuff. Now look down here a little bit. There's a whole bunch of data. Wow. I'm not going to get deep into this specifically, but look down here. We start to see these. Let me kind of zoom in on this. Try to. Is it getting bigger? Yeah. Oh shit, now I don't know where I am in the article. There it is. Okay. Okay, now the specifics of all this shit, like I don't know what N. Hanes is. Is that not Hanes? Is that some other brand of underwear? I have no idea. I'm almost certain it's not that. That doesn't matter at the moment. Look down here. That's the p-value. So whatever this part is talking about, a rise in ambient temperature of 1 degree Celsius correlated with 0.001 degree, whatever the hell that exactly means, did they find evidence for that? Yes, hell yeah, big time for this. P is less than that, that's huge. Now what do you think about this? Is it as good? Is it still okay though? Really, yeah. But do you notice what's missing from every article you ever look at? There's no freaking alpha. There really isn't. So in the real world, there's no freaking alpha. There's none. They just report p-values because I, for a certain article, certain study, could have my own level of proof. Just like a jury is made up of people that have their own levels of proof. So when they tell me p equal to 0.013, this one guy can be like, dude, that's pretty good. My alpha is 0.05 for this. That's really good. And then I could be like, my alpha is 0.01. Screw that shit. Right? That didn't meet. My alpha is 0.01. That didn't get good enough. So I'm not impressed. Next. Right? You kind of see what I'm saying? So they're going to report p-values because everybody's going to have sort of their own level of, their own alpha. What enough evidence will be. So yeah, a big part of what we do in this class is not real. They give us alphas. Why do they do that? Because we don't know enough yet to develop our own alphas for different situations. So the more you know a certain idea, the more you know statistics, you can kind of develop your own alpha for different situations. You don't know shit yet, to be honest, right? Hell, man, if you just took this class, you don't know enough yet to develop it, so we give you alphas for these problems. So you kind of have a benchmark to compare things to. Okay, maybe. The takeaway there, somebody's going to like, my teacher told me I didn't know shit. Damn. All right, gotta be careful about my sound bites. Let me see, anything else interesting? Here we go, here's some 95% confidence intervals. Neato. Anything else interesting in here? Look at that beautiful thing there. Let's see. All right. Blah, 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 blah. All right, I'm going to stop looking. It looks like there's nothing else. Okay. But at least I really wish anything you're interested in, there is a journal related to that topic. There just is. It's insane. Right? Anybody interested in music? Oh, there's a journal of music. There's a journal of musical instruments. There's a journal of pop culture music. There's a journal of whatever the shit. And in there, you will find statistical analyses of things. Anybody ever, I think most of you guys probably use Spotify or something else. Anybody use Pandora ever? I love it. Somebody's like, no. What's wrong with you, Jeff? Well, I do because I'm an old fogey, so, you know, I'm still in the Facebooks and the Pandoras. Pandora is interesting because it was developed by math people who happen to like music. So when you identify a piece of music you enjoy in Pandora, I know you don't use it. You can stop. I love it. This guy's like, you're not going to make me use it. You're going to probably want to use it even less after he says. So, like jazz. Anybody like jazz? You guys? I love it. You just, I hate that. Everything sucks, Joe. Jazz has like 500 components they've identified to it. So one could be, is the percussion front or back? Is it in the background or is it forward? Same thing with voice. You could talk about how many instruments there are and how prominent they are in the song. 500 elements. So when I say I like a particular jazz song, it'll actually see another song, is it very far away from the elements that were in the song I liked, to come up with another song for me to try. And if I don't like that one, they'll go the other direction on a few of the elements, because it could be this way on one element, or it could be the other way on an element. You guys kind of see what I'm saying? So basically what I'm trying to say is, much better than Netflix, for example. Oh, you like this thing that has a guy named John in it. You'll like this other movie, it's got a guy named John in it. What the hell? I mean, that's basically how Netflix works, I'm sorry to tell you. Right? Okay. Sorry. So, I just wanted to show you a real life situation. Let's do this. Let's do one more. We're going to do two more, sorry. We're going to do two more hypothesis tests and we'll call it a day. All right? Let's do the one on the, I'm going to let you guys do the one on the opposite side. And I will warn you, I think I already warned you, but just to remind you guys, you will be using T-scores. Can you identify why? Read through that, on the back of that, the one about credit card debt. Oh shit.
That's a little low,
I like, some of you guys are probably looking at that amount and saying, I wish, but I mean, after grad school, I'm like, oh my God. I had a very plastic life in grad school. All right. This is not evil. This isn't. You just have to pay attention. Why am I going to use a T-score on this problem? Yeah.
You just give it regular standard deviation?
What do you mean regular standard deviation?
Not population.
Well, how do you know? It came from a sample. Yeah, it says, from a sample of 81, I found this mean, I found this standard deviation. But people don't stop and think. And again, this is where I have people say, we know the standard deviation, so we can use z-scores. That doesn't make sense. Which standard deviation came from a sample? T-scores, right? Plus n is greater than 30, so that's it. All right, so I already did part B for you, so do the rest of it. Call me over if you need some help.